Hey, accelerator algebra 2 Stirp here. This is for L. So let's take a look what we got going on here. Solving quadratics by taking square roots. Okay, let's see what we're going to do with these problems. So remember quadratic, oops, I didn't mean to go to that. Quadratics are something that's raised to the second power, okay? Technically, it is a parabola. Okay, it doesn't matter what the variables are, it's a parabola that we'd be dealing with. All right, so just kind of review. So if we remember when we're adding these together, we add the real parts to the real parts, so that gives me 5, and then this part would give me plus 3i, and you want to have the real part first and the imaginary part second. Then the second one, combine the real parts and then the imaginary parts. This one, make sure you 9 minus 4 is 5, negative 2 minus minus I, that becomes, if I distributed that here and here, that would become a plus I, so negative 2i plus I is negative 1i, or just negative I. And then this problem here, the real parts give me negative 6. Imaginary parts, I have to convert 20. That's going to be 4 times 5, the biggest perfect square. So 20 becomes the same thing as 2 root 5. Root 20 is 2 root 5. So then that, I guess that would be 2i root 5. So I have 1i, so it's going to be 3i root 5. Okay, so now we're going to multiply these. It's going to give me 12i squared. Hey, what did we say I squared was equal to? Yeah, it's equal to negative 1, so that's going to be 12 times negative 1, so that gives me an answer of negative 12. This next one will be 64i squared. I squared is negative 1, so my answer is negative 64. 9i squared is going to give me negative 9 because I squared is negative 1. This is going to give me 16i squared, which, oh, and realize it changed to a positive 16 because I squared this as well, and then that's going to give me negative 16 for an answer, so overall comes back to be negative. Same thing on this one. This is negative 7 times negative 1, which will be positive 7. And then 6 to the third is 216. 6 times 6 times 6. I to the third. What did I to the third become equal to? Yeah, that's right. I to the third is equal to negative I. So my answer here is negative 216i. All right, so let's start simplifying these. So we know that it's going to become I root 12. I can break 12 down to 4 times 3. So the square root of 4 is 2, so I get 2i root 3 for an answer on this first one. Second one, we don't want to have an I in the denominator, and we could take care of perfect square. So I'm going to multiply both top and bottom by negative root 2. Okay, so on bottom, this bottom would give me root 36. Okay, so the negatives are gone. I want to do it that way. Hang on, let's pause on this one. I'm going to go back and erase that. I think I overstepped my bounds and I goofed up the order of operations. I'm sorry about that. Okay, so I know on bottom I'm going to deal with this. I root 18. Root 18 breaks down to root 9 times 2, which gives me 3 root 2. And then, so on this particular problem, I'm going to multiply the bottom by root 2, and root 2 top and bottom. I'm also going to multiply top and bottom by I and I. So on top, I'm going to get negative 2i root 2. And then on bottom, that's going to give me I times I is I squared, which is negative 1. And 18 times 2 is 36. So I'm going to get negative 6 on bottom. Negative over negative is positive. Reduce the outside 2's. So I'm going to deal with get I root 2 over 3. On this particular one, we could possibly start reducing it a little bit. On top, I'm going to get root 20 over root 10. And then we can go ahead and reduce top to bottom. That cancels into that, and that gives me that. So I'm left with an answer of I root 2. I'll FOIL this one out. These are not conjugates, so I'm going to get negative 4 minus 8i minus 2i minus 4i squared. This right here is going to become positive 4, so positive 4 added to negative 4 is 0. And then 0 minus 10i, or you could just leave the answer as negative 10i. It's your choice. I think both answers are correct. Go ahead and FOIL this out. So I'm going to get 36 minus 9i minus 8i plus 2i squared. Remember, 2i squared is going to give me negative 2, so 36 minus 2 is 34 minus 17i. These are conjugates of each other, so the outside and the inside are going to cancel out, so that's going to give me 25 minus 9i squared. Negative 9i squared is going to turn into positive 9, because negative 1 times negative 9. So that's going to give me an answer of 34. Let's rewrite this to look like this. FOIL it out. These are not conjugates of each other, so I'm going to get 9 minus 12i plus 16i squared. 16i squared is going to be negative 16, so 9 minus 16 is negative 7 minus 24i. These are conjugates, so I'm going to get 121 minus 36i squared. So that's going to be 121 plus 36, because this becomes a negative 1. And so that's going to give me 157. All right, so some quadratics can be done by taking square roots. So if I take the square root, I'm going to get x equals plus or minus 8. Okay, there's always 2 roots to it. Next one, I'm going to divide each side by 5 first. Take the square root of both sides, so I get x equals plus or minus 4, so there's 2 solutions. Next one, I'm going to go ahead and add 11 to both sides, so that was at 98. Take the square root of both sides, so you got the plus minus root 98. 98 breaks down to 49 times 2. Okay, so that's going to give me plus or minus square root of 49 is 7 root 2. Again, if we have questions, please let's ask about those in class, all right? Now, what's going to happen when we have a little bit more to the problem? So I'm still going to take the square root of both sides. So I get x minus 4 equals plus or minus 6, because square root of 36 is 6. And then I'm going to add 4 to both sides. Let's combine like terms. So I get x is equal to 10, and x is equal to negative 2. So we have 2 solutions to this problem. This particular problem, I'm going to divide both sides by negative 5 first. So that's equal to 1. We're going to take the square root of both sides. Don't forget the plus or minus. So x plus 8 equals plus or minus square root of 1 is 1. We're going to subtract 8. So I'm going to get negative 8 plus 1 is negative 7. And negative 8 minus 1 is negative 9. All right, so those are just some hints for on this problem. All right, next problem. Root square root of 121 is 11. Don't forget the plus or minus 11. So then we're going to add 4 to both sides. And then divide by 3. Let's take care of that first. So this is going to give me 2 answers. Negative 11 plus 4 is 15. Negative 11 plus 4 is going to give me negative 7. And then we'll divide both of those by 3. So x will equal 15 over 3, which is 3, and negative 7/3. So there's my 2 solutions to this problem. Next problem, I'm going to subtract 7 from both sides first. So I'm going to get negative 72. Divide both sides by negative 3. So I'm going to get positive 3 goes into there 24 times. Okay, because I divided by the negative. Take the square root. Don't forget the plus or minus. Oops, I'm writing too much. 24 breaks down to 4 and 6. That's the biggest perfect square. So plus or minus 2 root 6 is this answer. Next one, I'm going to add 3 to both sides first. That's equal to 8. Multiply both sides by 16. What is 16 times 8? I'm going to do it over here. 48, carry the 4, 128. Don't take the square root of both sides. Oops, I don't need that. I already took the square root of both sides, so don't forget the plus or minus. That breaks down to 64 and 2. 64 is the largest perfect square, so m equals plus or minus 8 root 2. If you heard that burp, that was Mr. Lefebvre saying hello. Number 22, the tricky thing on this one is we want to multiply everything. Let's clear the denominator. Let's multiply everything by 6 because 3, 6, and 2 all go into 6. So 3 goes into there twice. 6 goes in there, so that leaves me minus 5. And 6 goes in there, so that's 15. We're going to add 5. Let me expand my screen a little bit. Divide by 2. Take the square root of both sides. Don't forget the plus minus. I can't break root 10 down any further, so it's got to stay that way. So my answer to this one, once we add 2, is 2 plus or minus root 10. All right, so now we're going to start dealing with some complex numbers. So I'm going to subtract 30 from both sides, so I get negative 25. I'm going to take the square root of both sides. So x equals plus or minus 5i. Okay, the I comes from because of the negative and the radical. Divide each side by negative 4. And so it's going to give me a negative answer. 4 goes into 14 3 times. 36. Take the square root of both sides. Don't forget the plus minus. X equals plus or minus 6i. Next problem, I'm going to subtract 17 from both sides first. So that's negative 21. Divide each side by 3. Gives me negative 7. Root, don't forget the plus or minus. X equals plus or minus I root 7. Next one, take square root of both sides. So x minus 5 equals plus or minus 7i. Add 5 to both sides. Get that for an answer. This next one, I'm going to divide each side by 5 first. Root, don't forget the plus minus. X plus 3 equals plus or minus 4. Subtract 3. Do the arithmetic. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Next problem, let's add 32 to both sides. Divide each side by 6. Now we're going to take square root of both sides. Don't forget the plus minus. So there's going to be a plus or minus, there's going to be an I in there. 12 breaks down to 4 and 3. So the square root of 12, or square root of 4 is 2. So I get 2i root 3, plus or minus that. Add 2 to both sides. That becomes our answer. Next problem. I'm going to add 2, or subtract 2 from both sides. Divide each side by 5. Take the square root of both sides. Root. Don't forget the plus minus. X minus 3 equals plus or minus root 6. I cannot break root 6 down, so then add 3 to both sides. Next problem, take square root of both sides. So I get 3x plus 5. Don't forget the plus minus. Equals plus or minus 3i. Then we're going to go ahead and subtract 5 from both sides. And divide both sides by 3. And it's your choice if you want to leave this over all over 3, or you could break it into 2 fractions. So you could have this for an answer. The reason that I would take place is the 3's would cancel out. So either answer is fine, whichever one you feel more comfortable with. All right, so let's graph this. So this is going to have a 4, negative 3 for a vertex. My pattern graph will work. Right one, up one, left one, up one, right one, up 3, left one, up 3. And we have this. Now, my friends, this doesn't need to cross the x-axis, but we can't, our pattern graphing didn't identify it right away. Okay, so if we wanted to find the x-intercepts, I'm going to go 0 equals x minus 4, quantity squared minus 3, add 3 to both sides, take the square root of both sides, don't forget the plus minus. So I'm going to get plus or minus root 3 equals x minus 4. Let's add 4 to both sides. So where it crosses the x-axis is at 4 plus root 3, comma 0, and 4 minus root 3, comma 0. So those are both irrational roots, meaning we know we don't have a decimal exact value for it. Next problem we'll go ahead and do in red. So I have a vertex of negative 3, 4. So negative 3, 4 is up here. Pattern graph is going to go right one up 2, left one up 2, right one up 6, so it goes off the screen. So is this going to cross the x-axis? No, but let's see what happens when we go and solve this problem. Subtract 4 from both sides. Divide by 2. Take the square root of both sides. Don't forget the plus minus. So that's going to give me plus minus I root 2 equals x plus 3. So then my answer to this is x equals negative 3 plus or minus I root 2. Okay, this solution exists, but it exists in the imaginary number system or the complex number system, okay? It does not cross the x-axis. So that's kind of a key to realize. When it doesn't cross the x-axis, we do have solutions, but they don't cross the x-axis because they're imaginary. Okay, bring questions to class. Have a great day. Take care of one another.
Stirp out.
Bye-bye. And Stirp is out. Mr. Faber says Stirp's out.